Okay, let's dive into this. You ever have that moment with an AI agent where it just completely forgets something you literally just told it? Yeah, it's super frustrating, and it's a huge problem. So today, we're going to get into why building a real, intelligent memory for these agents is way more complicated than just keeping a simple chat log.
So here's our game plan. First, we'll talk about that forgetful AI assistant we all know and, well, we know it. Then we're going to diagnose why the standard approach, the chat log, completely fails. After that, we'll explore a much smarter way to think about memory, look at a better architecture, see it in action, and wrap up with the one question you really need to be asking. All right, first up, the forgetful AI assistant. You know the drill. You're in the middle of a complex task. You've fed the AI all the right context. You're making progress, and then, poof, it's gone. It's like talking to a goldfish, and it's a massive roadblock to building anything truly useful. So it's the obvious question, right? Why is it so forgetful? Well, the answer really gets to the heart of a fundamental design flaw in how a lot of these systems are built. It's why it feels like you're hitting the reset button every few minutes.
And the problem really starts right here. Look, we as humans have conversations that are this messy, tangled web of ideas, context shifts, and shared understanding. But most AI agents, they just see a flat, straight line, a list of questions and answers. It's kind of like trying to appreciate a beautiful piece of music by just reading a list of the notes in order. You lose all the depth, all the harmony, everything that actually matters.
Okay, so we see the mismatch. Now let's get into the nitty-gritty. In this next section, we're going to diagnose exactly why that simple chat log approach is basically doomed from the start for any kind of serious real-world application. And what's so sneaky about this? Is that the flawed model? Well, it looks so logical on the surface, right? You just save everything the user says, everything the assistant says, turn it all into vectors, and then do a quick search to find relevant stuff later. And yeah, for a flashy demo, it works fine. But the second a conversation has more than one moving part, the whole thing just completely falls over.
And this is exactly why it breaks. A flat log loses all the important stuff, all the context. It has no idea which messages are part of the same topic. It can't figure out what a simple word like yes is referring to. It just flattens everything, stripping out the relationships and the meaning that make a conversation, well, a conversation.
And this quote it absolutely nails the problem. A simple log tells you the sequence of events. It does not tell you what's actually relevant right now. And for any complex task, that's really the only thing that matters.
So, this is the turning point. We have to stop thinking about memory as just one big bucket you throw everything into. A truly smart agent needs a much more sophisticated system with different layers of memory. Let's break down what that actually looks like.
First, you've got the basics. Think of turn memory as just the raw transcript, who said what and when. Simple enough. But the real magic starts with thread memory. This is what lets the agent understand that we're talking about the same thing we were 10 minutes ago. It groups related turns together into a coherent subject.
Okay, building on that, we get to the next level, semantic fact memory. This is where the agent starts to get really smart. It pulls out key facts from the conversation, so they're not just lost in the text. Things like, the user likes short answers, or, in this project, site means a facility. These become reusable pieces of knowledge.
And then, we get to my favorite layer, the most valuable one, operational decision memory. This is basically behavioral memory. It's not about what was said, it's about what was done and whether it actually worked out. This is how an agent learns from its past mistakes and actually gets better over time. It's the difference between knowledge and wisdom.
So we know what the different layers are, which is great, but how in the world do you actually build a system that can handle all that complexity? Well, the answer is to move away from a simple list and start thinking in terms of an elegant and incredibly powerful graph structure.
I mean, this comparison says it all, doesn't it? A flat log is just a list. All the relationships between ideas are totally lost. But a graph? It's a network. Those relationships, what answers what contradicts something else, they are explicitly modeled and saved. Context isn't destroyed. It's the very foundation of the whole system. And just look at the kind of power this gives you. In a graph, a node can be anything. A conversational turn, a company policy, a fact. And the connections between them can explicitly say things like, this answers that, or this contradicts that. This is how you actually preserve meaning. Okay, enough with the theory. Let's see how this multi-layered, graph-based memory makes a real, tangible difference in a high-stakes situation where a mistake could be really, really costly.
So picture this. A maintenance planner asks, can we schedule this job for Saturday? A simple agent might just say, sure, but a smart agent checks its memory layers. Organizational memory says, whoa, weekend work needs a supervisor's approval. It then checks external data. Oops, the permit is pending and the tech isn't even available. And then, and this is the key part, its operational memory remembers a past failure caused by using bad data. So what's the result? It doesn't just say yes, it gives a safe, context-aware response, preventing a huge mistake.
And this brings up an absolutely critical point. You have to separate different kinds of memory. A consultant's personal preference to keep it brief can't be allowed to override a company policy that reports must be formal. If you don't keep these domains separate, your agent has no way to make the right choice in the right context. It's a disaster waiting to happen.
So, as we start to wrap this up, I want to try and reframe this whole problem for you. The real goal here isn't just about building a better memory. It's about asking a much better question about what memory is even for in the first place.
This quote really is the key takeaway. The future isn't about just saving more and more text. It's about building a memory that actually understands things like context, scope, and authority. It's a huge shift from just simple storage to actual intelligence.
So, let's just stop asking, how do I store the conversation? The real question, the one that's going to lead to powerful, reliable AI agents, is this. How do I structure memory so the agent can safely pull up the right fact, the right policy, the right preference at exactly the right time? That question changes everything.
And that's really the final thought I want to leave you with. When you look at the systems you're building or using, ask yourself this. Is its memory just a flat, lifeless record of what happened in the past? Or is it a dynamic, structured system that represents true intelligence?